Let's transition into our next type of graph, which will be circles, and this will correspond to assignment number 23. Once again, I would recommend that you watch these in sequence and that you also pull up the notes and examples ahead of time. If you're able to print them, even better, and follow along like you would in class, and hopefully, we're doing the best we can with what we have here. All right, so example number 1 here. You see it on the screen, you see it in the printout in front of you, you see it on the board. We're going to have these boxes for you to fill in your answers. We're going to start out with, what if we have an equation in the form that's called a center radius? We're going to fill in the information about the circle, and we're going to use that information to graph it. As always, we try to start with one that's hopefully kind of easy to begin with. So here would be the deal here. If you look at your notes, you'll see that the standard form, the center radius form, we'll talk about what's a center, what's a radius. I think you understand those terms probably. But you'll notice that that format and that equation match. That's why this equation was actually already in the box. It's already in what a person would call center radius form. So awesome. And the reason it's called center radius form is because it's very easy to identify the point that would be in the center of the circle. It's a point, ordered pair. And you notice that the x-coordinate of your center point is going to be the number being subtracted from x. Okay, so on this one, you'd hopefully look and go, oh look, 5 is being subtracted from x. So that would be the x-coordinate of that center point. All right, h, the number being subtracted from x, is your x-coordinate. All right, the y-coordinate, this is a little tricky on this one. The y-coordinate of your center is the number being subtracted from y. That's a little tricky here because the format requires minus, whereas that says plus. So you got to do a little mental gymnastics here and say to yourself, and I've got another way to do this if this gets confusing to you. You would change that plus 3 into minus negative 3. So plus 3 is the same thing as minus negative 3. Wait a minute! That really confused me there, Mr. Sausage. Well, okay, let me put it a different way. Maybe this is easier. If you want to identify your center, you look at the expression that has x and say, what would x have to be for that to equal 0? 5. 5 minus 5 would be 0. Okay. What would y have to be for that to equal 0? Negative 3. So again, use that logic if you prefer. Either one. So, the ordered pair 5, negative 3 is going to be our center point. That's in the center of the circle. And then the circle will radiate from there. Radiate, radius, all right? You're probably familiar with the idea that a radius is basically how far is it from the center of the circle to the circle itself. How far do we travel from that center to build this circle? And that's called the radius. We can get that radius from this equation. Now, the radius is r, not r squared. All right, so be very careful with that. All right, the radius is r. I guess we should go ahead and put on our pirate hat since we're talking about r. But the idea here would be this. The number that's actually in the equation is the radius squared. So for this question, the radius squared, r squared, happens to be 36. So to discover the radius itself, we would need to square root that. I'm doing the work outside the box, and I'm putting my answer in the box. I ask you to do the same. So wouldn't the radius here actually be 6? Right? Because the square root of 36 is 6. So the radius is 6. And therefore, from that center point, I'm simply going to suggest that we go 6 units to the left, to the right, up, down, from the center, plot those 4 points, and then we can freehand it from there. That'll work for me. So if the radius is 6, it's 6. I'm going to go to the center point here and on the graph paper, and if it extends beyond the graph paper, don't worry about it. So 6 units to the right, 1, 2, 3, 4, 5, 6 would give us a point here. And then we go back to the center and we go 6 units to the left. And and plot. So just, go radius. 6 this way, 6 this way, 6 this way, 6 this way, which is probably off the board. I didn't plan ahead real well. Board space is really tough here. And then, just freehand it from there. So as long as we can identify the center point and the radius, we're good to go. And don't worry about me being an art critic. If your circles look a little bit mushed, look at mine, okay? So if you can identify for me what the center and the radius would be, and then where they belong essentially on the graph paper, that'll work. I hope that totally made sense. If not, hopefully we'll reinforce it with some future examples. So there's example 1 for you, all right? Arr.